I start slowly because we're a little bit ahead of the time, but I think that is good for the discussion afterwards. So, as mentioned already by our chair lady, I will talk about circular economic potentials in urban construction with bio-based concrete constituents. My name is Wolfram Schmidt, and I work at the Federal Institute for Materials Research and Testing, which in Germany sounds even more bulky. It would be Bundesanstalt für Materialforschung und Prüfung. So therefore, we prefer to call ourselves just BAM, BAM. So, and with that, I would like to come to the challenges of the 21st centuries that we typically face. Certainly, this is above all, it's food safety, it's health and peace issues. But what we will see is that all those issues are kind of linked to the construction business, because construction business kind of equilibrates people, and if we do it in the right way, it can allocate the wealth of the earth also to those people, or to the entire world. And if we build adequate houses, adequate infrastructure, adequate urban areas and settlements, that will also create a situation where hopefully the wealth of the world is better distributed in the future. So therefore, I would like to elaborate particularly on the challenges that we face related to the construction industry. And these are definitively habitat, it's infrastructure, it's urbanization, that's what this conference is all about. It's environment. It is also the sustainability, which is getting more and more important in our world. And if we think about those 5 items, and I think Dr. Olonade has shown a similar figure early this morning, we will see that concrete is a component which is kind of responsible for all those challenges that we face. It is involved in that, and is a significant contributor to the challenges that we face with this. And the problem is certainly it is kind of inevitable. We had that in the earlier talks already before, because concrete is made of the constituents that make out the elements we can find in the outer Earth's crust. So the chemistry of the Earth determines also the construction materials that we can use in high amounts. And today, concrete is about 40 to 50% of everything that human beings consume. So that's a huge amount. But the reason for that is that it is the only material that is really sufficiently available on Earth. And what people often forget is that the carbon footprint of concrete related to other mass materials that we can use, you can see this figure here on the bottom, is relatively low. What is dramatic is the cement, but the concrete itself, because cement is only the glue in concrete itself is relatively good. But the problem is we consume it in a huge amount. It's everywhere in the world. Everywhere in the world we can find concrete structures, infrastructures, underground structures. And because of that high amount it is being used, it causes a lot of environmental challenges, between 10 and 20%, depending on the author and the study you look at. And that is certainly dramatic. And now we can start to complain, the environment is polluted, and that causes a lot of challenges, but certainly it is simply there. And instead of looking at the challenge, we should also look at the potential that we face in concrete, in the mass consumption of concrete. Since it is about half of everything that human beings consume, if we change only a little bit, it can create a tremendous leverage all over the world. So we should rather, instead of looking at concrete as a big challenge, we should rather look at it as a big potential for future innovation. If only we can make it possible to use cement in a more sustainable way, to use a more sustainable cement types, to use less cement in concrete, to use it more efficiently, to create better concrete, and to develop a kind of a change of mindset in the heads of the people and the standards to produce more sustainable construction materials, which are concrete and very similar. In all those 5 challenges that I mentioned before, the urbanization is a central element, because it kind of embraces the challenges that are accompanying it, like habitat. Urbanization requires houses to be built. It requires infrastructures, which are lifelines for interaction between people, and also for the economy. It requires resources, and it produces a lot of carbon emissions. And certainly the way how urban structures are being built also form how human people interact with each other, So therefore, they are a key element for sustainability aspects. And all this requires a lot of materials and a lot of technology. And in Africa, this becomes more dramatic than in the rest of the world. Here you can see how the urban population growth compared to 1960 in the red line in the world, and the blue line indicates how it is in Africa. So the increase of the urban population is dramatically stronger than in the rest of the world. And what distinguishes Africa from the rest of the world, if we take a look at the rural population, in the global rural population is the growth of the rural population is kind of leveling off. But in Africa, it's also increasing quite strongly, but the urban population is growing 4 times stronger than the rural population. So what does that mean? There are some predictions, for example, after the study by Dan Hornweg. Maybe he's listening, he is also registered, but since he is in Canada, maybe he's still sleeping, but he will join us probably later over the course of the day. He made some predictions about how cities will look like in Africa in the future. And he predicted that in the year 2100, 13 out of the 20 most populated cities will be located in Africa. This is not the case today. So there will be a dramatic construction demand in the future. Cities like Lagos, for example, are predicted to have about 88 million inhabitants. This is more than the whole country I'm living in, Germany, has. Also, cities like Kinshasa, Dar es Salaam will be extremely huge. And this will require a lot of construction materials, because this is another statistics that of those urban buildings that will be built in the year 2050, only this tiny little part is already existing. 80% are going to be built until 2050, and this is in 20 years. And this is in 30 years, and 30 years is really not long. So we only have these 30 years to become more sustainable, and we should not wait until these 30 years have passed. We have to act now. So we can discuss a lot theoretically, what is sustainability, what is more sustainable than the other thing. There are so many solutions like that require, if this is fulfilled, then this will be better, but we cannot wait for these theoretic if-then approaches. We have to use those things that already exist. And for the moment, on the large scale, that doesn't mean that it's the only solution, but on a global scale, for large scale production, concrete is there. It's the only feasible way, and whether we like it or whether we don't like it, we have to make the best out of it. And looking at those dimensions of urban areas in the future in Africa, this will require materials in volumes that are unprecedented today. So if there is a new challenge, sometimes it makes sense to look back into the history, whether there's a role model where something similar happened. And if we take a look at the history of cement and concrete, on top you can see a timeline of cement and concrete history. We don't know what is going to happen here, but we see in the history back, most of those milestones in materials technologies and cement production were kind of coined by European demands and by European developments. So let's take a look whether Europe could be a good role model for the urban growth and materials used in Africa. And therefore, I developed this figure together with a media designer here at our institute, and we try to compare this. And if we take a look at Europe today, unfortunately, we have to say we are completely blocked in innovation, because we have so many policies. We are like a machine that produces regulations, standard guidelines, new rules, new laws that are kind of manifesting the knowledge of the past, but they are blocking to step into the future. And those people who have the sovereignty to judge what is good, what is bad, what is feasible, what is not feasible, what is sustainable and not, those people can make a lot of money out of these regulations and out of the power they have. But at the same time, we don't see that not much is really changing in the environment. So those policies will probably be blown away by all the emissions that we produce. But at the same time, we have to say we love to teach others. We love to preach to others and say, do it like we do. We are the role model. At the same time, we stick to sitting in our thinking box, which is limiting our potentials to break free and become more innovative and think of ourselves. So that looks very dark to a certain extent, but let's think about it. And let's think, what if, for example, this individual way of thinking would be replaced by an Ubuntu way of thinking? like a thinking about the community, thinking about we, about the other people. What if this thinking box would fade away, along with all those isms that are still putting a lot of pressure on Africa internally and externally? What would happen if instead of producing policies and laws and guidelines and regulations, we would produce something which serves to the people? If we would produce something that serves to the people, that serves to the environment, and that's really needed by the population, then probably there is a way forward in an alternative way of thinking. And now if we think about role models, let us compare different regions in the world and their per capita annual carbon emissions, and look at these numbers in comparison to a threshold line, which indicates the per capita carbon emission that is required in order to limit the global warming by 2 degrees Celsius in the next decades. And we can see that all other regions in the world are way above this threshold line. And the only region in the world that is significantly below this line is sub-Saharan Africa. So if we think about role models, are these regions really good role models, or could possibly this region become a role model for the future and for the rest of the world? I think that's a promising way of thinking. But we also have to say, certainly, there's a lot to romance about Africa, and I love to be in Africa, and that's wonderful, but certainly there's also a lot of things which are not romantic, and we should probably stay a little bit realistic. If we take a look at this picture that I've shown, I would say the European picture is a dramatic exaggeration, or let's say it's an exaggeration. The African picture is probably a very, very positive future vision. Maybe it's a kind of a legend, but in every legend, there's also a little bit of truth inside. So it's definitely a potential future. And since it is a potential future, let's try not to oversleep this future, and let's try to work towards this future. But that means, in conclusion, for this part, the time to act is really now. We don't have time to waste. We have to act now. And the place where this action takes place is Africa. And this will contribute to the benefit of the entire world, to the climate and to the livelihood of the entire world. That is important. But then we have to ask ourselves, what are sustainable urban construction materials? What do they have to fulfill? And therefore, we first have to look at how structures have to look like in sustainable urban settlements. So first of all, certainly everything has to be structurally safe, and things also have to be environmentally friendly. And what is most important is it also has to be socio-economically sustainable, because, you know, just building structures that manifest the hierarchy of money and power from top down doesn't really help. We have to create structures where communication is possible, where livelihoods can be created, where markets can be created, so that structures that will be built, maintained, and don't have to be replaced. The structures have to serve to the people, then it is sustainable. So this is required for resilient urban planning, but this is also required for sustainable urban materials. They also have to fulfill these criteria, and that can be done by fulfilling what I would call the 3L principle, because there's an L word in all of these items. First of all, we have to make sure when we use materials to look at the load cases. And then we have to make a material selection that makes a lot of sense. In simple words, this means if there is compressive load, we have to use concrete. If there is tensile load, we have to use steel. And if there is a flexural load and we have to save weight, then probably timber is the best solution. But also some earthen materials where the load is not required, the heavy load, could be a best solution. And then we can find very good ways forward between materials and structures and try to develop synergies. And certainly we should not use materials only by principle, because maybe these materials are not available, then they are also not sustainable. Like, for example, timber in many regions in sub-Saharan Africa. And the next buzzword is low-key. Low-key doesn't mean low-end. It doesn't mean low-tech. It doesn't mean low-cost. It just means moderate. Keep it within a realistic scale. It doesn't make sense to build a 1 kilometer high tower somewhere in the desert where there's a lot of space to spread. Here, this figure on the top shows it. If you stack stories upon each other, that means that the lower stories always have to carry the sum of the stories upon them. And that causes that, for example, a 50-story tall building requires 25 times more materials for structural vertical elements than if you would use the same building and disperse it horizontally. And certainly we don't have to talk about 5% saving of Portland cement if we waste 25 times the materials by just building structures which are exaggerated. So low-key is really something which brings us into the future. It just means moderate structures. This also applies for elements that are under bending load. Sometimes a simple column can cause a lot of positive effect on the materials demand. And I like this picture. This is at the Hotel Firefly in Bagamoyo in Tanzania. I love this room. It's a wonderful room. And there was this really prominent column in the middle of my room. And at first I thought, this is really strange. It's kind of odd. But then I thought about the potentials of this column. I could put some TV screen on it. I could put a bookshelf on it. I could put paintings on it. And I started to love this column in the middle of my room. I really loved it. And it saves a lot of materials that would otherwise have to be supported by more steel and so on. And after all, the most important thing is probably to use local materials. This applies for everything related to sustainability. Local materials support the local markets, the other market players. It creates livelihoods and it saves transportation distances, certainly. So these 3 L's are probably important to keep in mind: load case dependent material selection, keep it low key, and also use local materials. And for that, I would like to give a short example how bio-based materials can really become a huge potential for Africa. So today, if we want to develop concrete, we use cement, water, sand, and aggregates. And if we want to make it more sustainable, we replace parts of the cement by using supplementary cementitious materials. And we want to increase the efficiency of the binder by reducing the water-cement ratio and adding chemical admixtures. So the problem is that the most established ones of these agents are not really available in Africa. Supplementary cementitious materials such as fly ash, ground granulated blast furnace slag, or even microsilica, they are not easily accessible and they have to be transported into Africa. So there would be alternatives here required. At the same time, these chemical admixtures, they are typically based on crude oil, which is in itself not too sustainable. And there would also be alternatives required because most of them are processed somewhere outside Africa and they have to be shipped in, which doesn't make a lot of sense. But there are those potentials. Kolawola has already elaborated on some of them. There are a lot of cement replacement possibilities coming from agricultural waste. Ashes from maize cobs, rice husks, sugarcane bagasse, cassava, groundnut. They can be pozzolanic materials and really help to reduce Portland cement in the binders. And the other alternative, I think, which is extremely important, are polysaccharides, bio-based chemical admixtures, which do not require crude oil as a precursor, like acacia gum or the barks of certain trees, cassava starch, cocoa waste, and so on. I'm not going to elaborate on that because that would be too technical, but there are some papers which I have listed up here where you can read a little bit more about that. And the interesting thing about that bio-based resources is that it is a perfect synergy. The vast urban growth in Africa requires enormous volumes of concrete. And Africa provides a lot of agricultural area, and a huge part of it has not yet been used. 60% of the unused arable land of the entire world lie in Africa, another 30% in South America. So 90% of the still arable land in the world without cutting off rainforests. So it's really usable arable land. They are in South America and in sub-Saharan Africa. So there is a huge potential for agricultural business to grow. And what comes on top is that the hectare yield in Africa at the moment is relatively low, and this will increase with more efficiency and new technologies for agriculture, so that agricultural wastes will also grow in the future and become more interesting. And therefore we have to make it more circular because there's a huge potential. And in Nigeria, for example, this is particularly the case for cassava. Cassava, Kolawola has shown this figure already before. Cassava production in Africa has grown. Most of the people will know what cassava is. It's also called mandioca, mandio, or yuca, or tapioca. It has been growing from 1961 to 2014, and it continues to grow. So it's a big potential. Nigeria alone produces about 20% of the global market. And today cassava is being harvested, then the peels are cut off, and the inner part of the root is converted into a food product. And what happens is that a lot of waste is produced, and this waste doesn't have a value because it is not suitable as an animal feeding. So it is just dumped away where it pollutes the environment and it requires space and it doesn't really create new values. But instead of that, it's possible to still obtain a chemical organic admixture to reduce the water content in cement. And then it can still be used as a co-fuel in an industrial process. And eventually, the ashes after the burning have pozzolanic properties, so they can help to replace cement and concrete. And with this way, from something which hasn't been used before, the waste, we can create a chemical value chain. And in addition, we can create a mineral construction materials value chain, and we can create them both without competing to each other. And if we think about it in a circular way, we have to use the agricultural production we take, which can be consumed as before. We take the wastes, first of all, in a wet process, we produce a chemical admixture that helps reducing the carbon emissions by increasing the binder efficiency. Then we get the wastes from this process into a pyrolysis process where we can create some chemical precursors plus energy, which can drive the next process. And we take the wastes from the pyrolysis and we put it into this into the next step, which is a high temperature step. For example, we can use a brick production, and we can use the wastes of the pyrolysis as a co-fuel in the brick production. And what finally comes out is not only the brick, but it's also pozzolanic ash, which can replace cement. And this way we can reduce the carbon emissions in cement production by reducing the Portland cement clinker content in cement. So in two ways, we can create green urban construction materials. And the good thing about it is this is a renewable resource, because the cassava plant grows with the next harvest, we have it available again. So that's a fantastic potential. And in this way, it is possible for the rural areas to produce not only farm products, which is a decreasing business these days, and deliver them to the urban areas, but in the next step, the wastes of the farm products should be used, and they can create energy and also other products, chemicals for the construction business, as well as materials for the construction business, which is growing. And from here, we can see that the urban growth also contributes to the rural development in Africa. And that is a perfect circle. It's a perfect synergy that can be used, and it's an enormous potential. And I think this is the way how people should think construction materials technology in the future. So the conclusion is that there's not a simple solution. There's also not a single solution. People always have to think about the entire framework, and materials concepts for sustainable urbanization have to be circular, knowledge-driven, interdisciplinary, and they have to be unbiased. In order to get there, it is important to train the students, the next generations, those people who implement this change, to train them better for the future challenges, which are yet unknown. And that means that the students also have to get a little bit of understanding of the beauty of our nature, of the history, of markets, of the nanoscopic and microscopic scale, at the same time also on the very, very large global scale and universal scale. And that requires that teaching also changes. The teachers, they can certainly provide the knowledge, but the students, they provide the nowness, and this belongs together. So the students have to learn from the teachers, and the teachers have to learn from the students. That's the only way forward to get into a situation where people are facilitated to cope with the challenges of the future. And then our future outlook can change from this perspective to this perspective. And that also means that we do not only have to talk to the today's decision makers, but also to the decision makers and talents of the future, the students, the kids at school, as well as the smallest one already. They all have to create an awareness, and then Africa can become a role model for sustainable, inclusive, and resilient urbanization processes. And with that, I would like to thank you very much for your attention. Sorry, I kind of exceeded my time, but maybe there's still time for a second time for some questions.
Thank you so much for your presentation. It was informative, and it was also very interesting. I don't see so many questions except a comment, and then Yeah, there's one here. What is the extent of ash generated in cassava process? What is the extent of ash generated in the cassava process?
Yes, thank you for this question. This is certainly varying from region to region and from cassava type, and also from the dimensions of the cassava. They are smaller and bigger tubers depending on the type. But in general, I would say the yield of peel of wastes, or let's say byproduct, potential future material, is about 20% of the tuber, or let's say, to be conservative, something between 10 and 20% of the tuber. But this is not yet the ash. From this part, we can obtain a certain amount of starch, which can be converted into a plasticizer for concrete. And the other part has to be burned during the production process. And then there is another 10% probably, which is left over as ash. So cassava is relatively good in terms of ash yield compared to other plants, because the skin of cassava is relatively thick. If you would compare this to rice husks, for example, it would be a little bit similar, but there are other plants where the ash yield would be significantly lower. This is certainly always a challenging question, but a challenging issue, because at the end of the day, sometimes countries produce huge amounts of crop, but then there's only 10% left from the wastes, and only 10% of these 10% are ash. If you compare this to a big business like concrete, like cement production, this is certainly sometimes very slow. So we also have to change our way of thinking that probably these ashes will not be intergrinded with the cement to produce a new cement type, but rather it would be necessary to produce some local distributors who allocate these ashes, which are produced locally, towards the local producers of ready mix of concrete, or not ready mix, of precast concrete elements, for example, so that the concrete producers purchase their cement as before, but then they save cement by using the local ashes into their products. I think that is the way forward, because otherwise it will be too complicated to create an infrastructure where all those cassava wastes are collected all over Nigeria, for example, to be delivered to the cement producers. I guess that would take about 20 years to create that infrastructure. So we should rather think into small grids using this. And that also means certainly more education to those producers of concrete. They have to learn about this potential, and they can save a lot of money.
Okay, thank you. Let's just take these two other questions before we go to the next session. What industrial investors are interested in cassava processing? And do you have an idea of the cost to produce this I can't really see this, bio admixtures or ash? I don't know if you got that all from.
I got the second one, but I didn't get the first one.
Okay, the first one. What industrial investors are interested in the cassava process?
Well, that's an interesting question. Unfortunately, too few. I think it takes a long time to convince people to see these potentials. I think they are on the table, but it's still a difficult issue to really convince the people, because people have their markets, not their markets, but they have their mindset and their way of operating, and they do not yet see the huge potential in it. But I think this will come. So there is a big interest, but the problem is there's a lack of actors who really want to pioneer this technology. If we think about the cost, that was the second question, I think it's relatively cheap, because we take a waste, we use a waste. And the first step to create an admixture out of it is much cheaper, because to make it very simple, we just have to boil the residues at about 70 degrees to dissolve the starch out of it. And then we have to dry it and make a powder out of it. That's it. And maybe it has to be cleaned, and maybe certainly this can be improved, but that's the simple process of obtaining chemical admixture out of it. And the next steps is you use it as a fuel. So you don't have a cost, you even save some costs by adding a fuel, and the residual product is the ash. Certainly this ash would require some grinding and so on, and also quality control, but it's certainly much cheaper than other materials that are available.
Okay, thank you. For sake of time, maybe you just attend to the other comments privately, I mean in the chat, while we'll go to the next paper.